We're in Chapter 2, Hand Tools, Shop Tools, Precision Tools, and Units of Measurement. We're going to review the broad ranges of tools that are utilized by truck technicians today. Wrenches, specifically torque wrenches, measuring tools, which are super important. We utilize them in engine and fuel systems, and the principles of measuring with micrometers and the related tools associated with precision measurements. We're going to be utilizing standard micrometers, inside and outside micrometers, and we're also going to be doing a bit with dial indicators and understand total indicator reading. That's important to know, and utilize digital and analog bore gauges and a variety of different bore gauge styles and the measurements that come along with them. Typically, the shop will provide tools greater than half-inch drive. So your 3/4 inch drive and 1 inch drive and all your heavy lifting equipment and specific high-value equipment are the responsibility of the shop. Here's a typical technician Snap-on roll-away box. The classic can hold quite a bit of tools, and it's a good long-term investment. We have common wrenches, open-end box, line wrenches, sockets, and ratchets. We're all familiar with those. My favorites are the miniature wrenches, and also we have a 6-point box wrench here, and we have some line wrenches. Those are required when you're working on tubing. And all types of hammers. It's pretty straightforward. Hammers, both pins. You have your very small sludge hammer, blacksmith's hammer, and you have your soft-faced hammers that are utilized in numerous applications. The correct use of extractors for broken hardware, taps and dies for making and improving thread chasers, thread pitch gauges, and these other tools are important because we're working on very high-valued assemblies, and we need to keep the end in sight where we can complete the job in the most professional manner. Here's a basic extractor set. There's also a square style that is a hardened tool steel, and these are effective to utilize for broken bolt removal. Of course, you have to match the correct pilot hole, and there'll be more on that as we go forward. Our basic torque wrenches are beam, dial, and click style. And also our electronic torque wrenches, which give us the maximum and minimums. They're settable and recordable, so those come in handy when you have to document a job if there's something that's torque related to a failure. So that's important to understand how to utilize the electronic torque wrenches. The turning effort produces 90% thread friction, 10% clamping force to give us 100% of torque. Torque wrench care is cleaning, wiping them down, backing off the settings, turning off your electronic torque wrenches, and calibration services have to be done at least twice a year. In some shops, they utilize mobile service calibrators that stop by and will test and calibrate the torque wrenches for that facility. Here's our basic click style torque wrench at the lowest setting. And here's a chart. These are available in charts that'll give you the net torque when you're utilizing an extension. And in micrometers, we can get to 4 decimal place. That's 1/10,000th of an inch. We have metric and standard readings, and we also have a variety of inside and outside diameters that can be accurately measured with the micrometer. Here we have our basic inside and outside micrometer. This is an inside measuring here that has we have a variety of tools that will go on to extend the range on the inside style. The outside style, we have up to 6 inches in our facility here at South. We have many sets of them, and they are precision instruments, and it takes great care when you're utilizing the micrometers. Our top line here is reading from 0 to 400 thousandths. Our bottom line is reading increments of 25 thousandths, as each barrel rotation is 25 thousandths in our standard micrometer. With our metric micrometers, each barrel rotation is 1/2 millimeter, so that's where you get your dimension on the bottom. Your line on the bottom is barrel rotations, and your top line is full millimeters. And that's the only difference between your metric and your standard micrometer. This is a Mitutoyo 1-inch micrometer with 5 decimal place accuracy. Using a outside micrometer requires some finesse that you have to gently tighten it and utilize the thimble to get a few clicks. You never put any unreasonable force on these instruments. Here's an example how you'd approach measuring a journal on a camshaft or a crankshaft, that you want to just get the micrometer to slip across the surface that you're measuring. Inside micrometers also what's shown here, but there's also the kits that have extensions that'll go on here, and it will give it a extended range out to, my set goes out to about 12 inches, and they're very accurate. They're accurate within a 1/2 thousandth, which is 5/10,000ths of an inch. So it's good to learn how to utilize these inside micrometers. Dial indicators are used widely in our industry, and it's important to learn how to use them correctly and how to figure the total indicator reading, which will give us above and below zero set point added together. This example shows the travel distance. Here at the bottom, the spindle and the probe is extending, and the what we're measuring is moving, and it has a variable dimension. It's going to show up on the dial. This is the revolution counter, which is a coarse measurement, and the indicator on the large bezel is going to give us the fine setting. So those are added together to give us a total indicator reading. Most of the dial indicators utilized in a truck shop are going to have a 100,000th rotational value. They go down as low as 10 thousandths. Certain sets are doing very fine precision, such as valve overlap would be something you would measure with a 10,000th dial indicator. But there's a variety of them out there, and they're specific to what you're measuring and what sort of tolerances are specified by the OEM. Total indicator readings, the highest positive and negative value added together. They're discussing flywheel concentricity, and they're utilizing a magnetic base, and they want to zero out the dial indicator on the flywheel flat surface, and in rotating the flywheel one full turn 360 degrees and record the highest and lowest setting, add them together and compare them to the OE's original equipment manufacturer's specification. This is an example of the common widely used magnetic base, and this is an example of the flex mounted. A lot of them come with a nice vice grip, so you're able to put them in a variety of locations and adjust them accordingly. The digital caliper gives us a variety of measurement functions. Here we're seeing the outside measurement, the inside measurement, and a step measurement, and also a depth measurement. So they have a good functionality in today's truck shop. We're going to utilize dial bore gauges in this class, and we're going to be setting them to get our outer round taper and within between 1 and 1/10,000th of an inch. There's a set point procedure of zeroing out the dial bore gauge. You rock it and you have to adjust it so that you have the set point for the manufacturer's bore size. That's going to be in your service literature, and it gives you the opportunity to set it, but also to take it in several locations. You're going to be doing it at the top dead center, at the top of the ring belt sweep, and at bottom dead center, and in the middle. So you have top, middle, and bottom dead center of the ring sweep. So we'll take a look at that. And it's where the ring lands here are able to go through their motion as the engine runs. We're going to have the top ring and the bottom ring are going to have a wear path here, and that's going to give us a top, our middle, and our bottom measurements. Those three are going to be done on 2 axes, so you're going to end up taking 6 measurements in the bore with the dial bore gauge and comparing them to the manufacturer's specification and wear limits that they may provide. Our 6 measurements per cylinder are going to go on a chart, and those charts are going to be compared to the specifications and to see where the rebuildability is for this particular engine. And if they're wet liners, obviously they can be replaced, but in some of our engines that are parent bores, we may not have the opportunity to go past the wear limit. So we're going to take a look at that as we move forward with our measurements. We'll be using all of these tools that you see here. Telescoping gauges will give us, do have some applications where they work, where we have cam followers, lifters, or tappets measuring those bores. They work for that. Small hole gauges, we'll be utilizing those. And also feeler gauges when we're adjusting overheads, for example, there's a finesse that you need to have to utilize them and to get good measurements in your work. Plastic gauge is utilized industry-wide to give us the tolerance between bearing and journal. That is essentially where the oil flows, and we're going to be demonstrating plastic gauge. We typically will be using green and red in our industry. There are some larger engines with greater tolerances, so you occasionally will use the blue, but the green and red are predominantly used in our industry, and they give us the final clearance. After you've mic'd everything and you've assembled everything, we're going to be utilizing plastic gauge to confirm that we have the specified clearance between the journal and the bearings. This is super important. It has to be done both in our main bearings and also in our connecting rod bearings, and we'll be doing plenty of that in class. The tools that shops provide, most shops have a broad range of tools and a tool policy, and technicians are typically required to have your 1/4 inch, 3/8, and 1/2 inch drive, essentially up to 1 inch and 25 millimeter. Some of us end up with larger tools that are specific to what we're working on, but the high cost and highly specialized are the responsibility of the shop, not the technician. We have a variety of chains and lifting attachments that have workland load limits, though that's pretty straightforward and it's common sense, and you have to understand that your safety is important in the shop. When we get into bolts, fasteners, in a big way, we're going to be cataloging every fastener that comes off our engines and creating a list so we know exactly how many bolts are in a location, what the function is, what the sizes, the thread pitch are, and that'll give us a good tool and a comfortable reinstallation when everything's organized that comes off the engine. Here we have washers, bolt identification, both metric and SAE. Now, this is all done in intro, but torque to yield bolts have a stretch value. In automotive, they're typically one-time use. In heavy truck, they may be utilized multiple times if they haven't stretched past a specific limit. The OEMs will specify what that is. So you're going to see that in cylinder heads, connecting rods, and crank main bearings. Always consult the service literature for the manufacturer's specs regarding torque to yield bolts. Torque to yield bolts have to be matched to the grade, and there's a clamping force. If they're not correct, the clamping force can be way off, and that can be a catastrophic failure for the engine that you're building. Adhesives and chemical sealing materials. We have anaerobic, which cure in the absence of air. That would be like Loctite. We have aerobic, which cures in the presence of air, typical of RTV, room temperature vulcanization. As you all know, RTV comes in different colors and are utilized for different applications. So we want to pay attention to manufacturer's instructions at all times. This is an example of having to heat components that have been put together with red Loctite, and the heat effect can damage parts, so you want to pay attention to that, and if you see any heat effect, you want to make sure that you replace those parts. We have interactive charts that are live that you can put a value on one side and come out with the other value. We are going to have some charts available, and plus you can also access them online. You have all of these can be pretty much done automatically, so you can compare any conversions quickly. And the actual value of a technician's toolbox is, is high, and we want to make sure that we have good quality tools that come with warranties. We all have our preferences, but we all know that the higher priced tools are going to be around for many years.